Hi, I'm Dr. Frank Summers, and welcome to Hubble's Universe Unfiltered. 2008 has been a year of real anticipation around here, because these 7 astronauts, the astronauts of Shuttle Mission 125, have been preparing for a shuttle mission to service the Hubble Space Telescope. Over its 18-year lifespan, astronauts have gone up several times to upgrade and repair the Hubble Space Telescope. And this was probably the most ambitious mission to date, a mission that we called Servicing Mission 4. Now, the astronauts have been preparing for it all year long, and here is an image of them in what is called the Neutral Buoyancy Laboratory. Basically, it's a giant swimming pool. And here you have the astronaut on the end of the robotic arm, and they are underwater because the air inside their suit lifts them towards the surface, while the weights around their ankles pull them down. And that makes them sort of float in the water, similar to the way they would float in space. So in the Neutral Buoyancy Laboratory, they can operate pretty much as they would do in space. And here they are practicing all of the servicing maneuvers that they will do on the spacewalks when they go up to Hubble. And in September of this year, we've gotten so far as to have the space shuttle go the long way up to the launch pad. The space shuttle sitting on the launch pad in late September for an October launch. 2 weeks before the launch, and now it's been delayed. It's been delayed till spring of 2009. What happened? I mean, all of this anticipation built up around here, all of the work, and now it's been delayed for 6 months. Well, let me explain it to you. And I'm really going to take a short story and make it a little bit longer, because I'm going to go all the way back to the beginning, just so you understand the full details behind all this. The beginning in this case means 1990. This was the space shuttle launch that carried Hubble into orbit on April 24th, 1990. Now, when I say carried Hubble into orbit, it takes Hubble into what we call a low Earth orbit. So, if this is the size of Earth, and this white line right here is the size of Earth's atmosphere. Let me blow that up for you so you can see it more clearly. Okay? Earth is about 6,400 kilometers in radius, and Earth's atmosphere is only about 100 kilometers thick. 1/64th of Earth's radius. So it's a very thin atmosphere. And the space shuttle lifts Hubble up to about 600 kilometers. So Hubble's orbit is about 600 kilometers above Earth's surface. Most people, when they imagine where Hubble is, think of, well, if Earth's here, Hubble's got to be way out here. You can see it really isn't. Hubble is just above Earth's atmosphere, and that's the really important point. For Hubble to get its really clear view of the universe, it just has to get above the atmosphere, so it's several times higher than the atmosphere. If you want proof of this, it's very easy to see in this image of Hubble, taken from the last servicing mission from the shuttle. Here you see Hubble, here you see the curvature of Earth, and you can see Hubble is really close to Earth. And you have to think about it. If you just sort of fill out the size of Earth, look at that small curvature you've got here. If you fill out the size of Earth in your head, you go, wow, Hubble really is just above Earth's atmosphere. And really, that's all it needs to be in order to get above the blurring effects of the atmosphere and get such sharp, clear pictures of the universe. So, being so close and being able to be visited by the space shuttle is a really good thing for Hubble. Hubble was designed to be serviced by the space shuttle. It turned out to be really important back in 1993 when we had our first servicing mission to Hubble because, well, you remember there was that small flaw in the mirror? Yeah, well, we were able to go up, service Hubble, and fix the problem with the mirror and restore Hubble to its full capabilities. Now, one of the things we did in that first servicing mission was we replaced an instrument called the Wide Field Planetary Camera with the Wide Field Planetary Camera 2. All right, this is Wide Field Planetary Camera 2, and it was on the ground during the time that we figured out that Hubble had a flaw in its mirror. And what we did with PIC 2 is we actually designed it to correct for the flaw. The optics in this instrument were changed so that they would counteract the flaw that was in Hubble's mirror. And so all we really do in this servicing mission was we just pulled out this sort of piano-sized instrument, pulled out Wide Field Planetary Camera 1, and then put in Wide Field Planetary Camera 2. And here again you see the astronaut on the end of the robotic arm doing the spacewalk, this time really in space. So these servicing missions have been invaluable for allowing us to change out the instruments in Hubble. So when Hubble was launched in 1990, it had a complement of 5 instruments. There are 4 instruments here, and each of these instrument boxes is about the size of a telephone booth. And then you've got the radial instrument here, which is sort of hidden by these guys. That's the wide field planetary camera, and as I said, that's about the size of a piano. During our first servicing mission in 1993, we put in wide field planetary camera 2, but we also replaced one of these telephone booths, and we put in something we call CoStar, which was basically a pair of glasses. So for the other 3 instruments here, CoStar put in corrective optics to help them adapt to the flaw in the mirror again as well. So this one had the fix already in it. The CoStar provided the glasses to fix the other 3 instruments. In servicing mission 2 in 1997, we added in a near-infrared camera, a camera that looks in the infrared wavelengths that are a little bit longer than visible light. And we also replaced the spectrograph, put in a new spectrograph. Then in 2002, we put in called the advanced camera for surveys, another camera into Hubble. And finally, what was planned for 2005 was to put in a 3rd generation of a wide field camera, as well as put in yet another spectrograph. So you can see that over the history of Hubble, every single one of the instruments has been replaced. And, you know, I sort of think of this like the computer I had when I was in college. I got my first computer, around 1989, and I kept that box for over a decade. And you may say, well, wait a minute, computers changed a lot. Well, computer hardware changed a lot, but I kept the same box. What I did was I pulled out the hard disk and swapped in a new hard disk. I pulled out the CD-ROM and then swapped in a DVD. I even pulled out the whole motherboard and got rid of my 286 processor and replaced it with a 486 processor. And then a few years later, I pulled out that 486 processor, swapped in a Pentium, and so on. The components inside the computer changed over time, but the box was basically the same. And each time I upgraded the components, it felt like I had a new computer. The same is true with Hubble. Basically, the basics of Hubble don't change. The tube, the mirror, all of the basic electronics, they don't need to change. What we're changing are the science instruments on the back end. And each time we make changes, we get upgraded to the new technology. And you know what? It really does feel like we have a brand new telescope. Now, I said this was slated for 2005. Obviously, it didn't happen in 2005. Unfortunately, in 2003, we had the Columbia tragedy, and the Space Shuttle fleet was grounded for 2.5 years. The Space Shuttle fleet returned to flight in 2005, and in 2006, this servicing mission was then put back onto the shuttle schedule. And it turned out that the timing for it was scheduled for 2008. Originally, the idea of delaying this servicing mission until 2008 was really actually quite scary, because the batteries on Hubble were decaying. Now, here are bays 2 and 3 on Hubble. Hubble has all these various doors you can open, and they're called the bays. This is bays 2 and 3. And if you open bay 3, you see on the inside this big black box. These are Hubble's batteries. Now let me note that this is a picture of Hubble in space. This is the real Hubble Space Telescope. This is a mock-up of Hubble on the ground. We have a lot of spare parts and mock-ups and test facilities on the ground. So these are batteries on the ground, not actually the batteries there. But inside bay 3 and bay 2, there are 2 sets of batteries. And batteries have a tendency to wear down over time. Now, some of you may say, wait. Hubble is powered by solar arrays, isn't it? Yes and no. As Hubble does get power from the sun through its solar arrays. But as Hubble orbits Earth, it goes from daytime to nighttime, to daytime to nighttime. Every 97 minutes, Hubble goes through both a day cycle and a night cycle. So it's charging the batteries during the day cycle, and it's discharging the batteries during the night cycle. Over 18 years, Hubble has done 100,000 orbits. That means 100,000 charge and discharge cycles. And if you've got, rechargeable batteries at home, you may know that rechargeable batteries tend to lose their maximum power over time. The same is true with Hubble's batteries. And here's a chart to show you sort of the measure of the power in Hubble's batteries over time. And so here is launch in 1990, and you can see the battery charges between 500 and 600 ampere hours, and slowly it starts to degrade. And we got kind of worried in 2002 to 2004 when the ability to maintain a charge started to decrease markedly. And if you extrapolate that, you can see that around about 2008, 2009, it gets down to about 100 ampere hours. And this reaches a critical level because Hubble needs enough power just to maintain its basic control systems.